Welcome to the final week of the quarter, your final week of math videos. We're talking about loans. So as exciting and wow, we're making so much money last week with these annuities, with compound interest, with all this stuff. This is the dark side. This is the depressing side. Loans, you pay a lot of interest, and we're going to talk about exactly how much. So the good news is that the loan formula might look a little familiar. It is the exact same formula as the payout annuity formula. And mostly what we're going to be talking about in our loans section of this class are car loans and home mortgages. Okay. Also learned how to say amortized today. Conventional loans, also called amortized or installment loans. So these are not related to payday loans, add-on loans, or other loan types where the interest is initially calculated. Here is going to be interest is continually added depending on current balance. Okay, so same formula as payout annuities. So lucky for me, I have the payout annuities formula right here, but you probably don't. So I'll pretend I don't have it either. We'll type it out together. We got this formula, very, very similar. Just now, instead of making money, we are spending money and getting charged a lot of interest. So again, as a summary, compound interest, we only have one deposit, and then the interest keeps growing on itself. Annuity is we keep on depositing, like building towards our 401k plan or something like that. 401k, no plan. Well, hopefully there's a plan somewhere else. Anyway, payout annuity is withdrawing, like after retirement. We're still making interest, but the balance is going down because we keep withdrawing because we want money. And loans are going to be many payments and many payments. Yeah, okay. We're going to start with Race Car Rita. The names in this video are even worse than last week's. We got Race Car Rita in example 7.10. And she can afford a monthly car payment of $250. After some research, she found that she found a bank that offers a 5-year loan at 7% annual interest, which I don't remember what my interest rate was on my car. Anyway, I hope it wasn't 7%, but maybe it was. Anyway, so if she chooses to take this loan, how expensive of a car can she afford? So we're going to look at this. P naught is the initial balance of the account. It's the amount of the loan. P naught is what you're buying. If you're doing a car loan, P naught is going to be how much the car costs. If you're buying a house, P naught is going to be how much does the house cost with all the additional. Yeah, anyway, the amount of the loan that we're taking out. So we're looking for the P naught here. So let's copy this formula down. Copying the formula down is a very good strategy for a lot of these things. P naught is going to be D times 1 minus 1 plus R over K. Sometimes you can include parentheses, especially if you're using like Desmos, on those exponents divided by R over K like so. And now we just fill in the variables. So the monthly car payment, that's our D. That's $250 right here. 5-year loan, that's our N. 7% annual interest. Has a little bit of a trick. And actually, we were told earlier to assume that it's monthly. I think this is a typo. There's a lot of typos in these notes. We're going to assume that this interest is monthly, which matches our car payments. We're going to have a 7% monthly interest. Wait. 7% interest is still 7% annual interest. Sorry. Still 7% annual interest. And it's just split up every month. So that's 7% divided by 12 would be the monthly interest. This is normal. Just forget that I'm convoluting things. This is what we have right here. So monthly car payments, $250 a month, times 1 minus 1 plus. Our interest rate is 7%, divided by K. 12 times a year because it's monthly. So K is 12. Negative N, it's a 5-year loan, times K, which is still 12. All divided by R, which is 0.07, divided by K, which is still 12. And we type this all into Desmos. Or your own calculator, or an online calculator, whatever. Let's just type it out like it's written. So we have 250, parentheses, 1 minus parentheses, 1 plus, 0.07 / 12, tab to get out of the denominator, parenthesis, caret, shift 6, parenthesis, -5, asterisk, 12. It almost sounds worse when I just read it all out loud. Maybe I should just type it. And then before we write our answer down, we double check. Does this look exactly like what we have down here? Compare your notes with what you typed in. It should look the same. If you're having trouble getting it look right, send me a message. Give me a screenshot of what you have or something like that and say, hey, this is what it's doing. How do I get it to do what I want it to do? But either way, we're going to have our answer of $12,000 and $625.50. So this is how expensive of a car we can afford if we want our car payments to be $250. So if we only want to pay $250 a month for our car, this is how much we can afford if we want to pay it off in 5 years with the interest from this bank. A pretty decent, pretty nice car. I guess depending on your definition of a nice car. It's a nice car to me. And that's part A. Part B and part C, these are the real sad things. It's worse for houses, but we'll see what it looks like for the car. So what's the loan's total amount, including interest? That's part B. The total amount, including interest. That's how much do we have to pay in this 5 years? Total amount, including interest, is how much are we paying over 5 years? That's another way of rephrasing the question. This is how much the car is costing, but we're paying more than this because we have to pay interest. Well, it's $250 per month. There are 12 months in a year, and we're doing that for 5 years. So let's multiply this all together and see how much we're actually paying the bank. 250 times 12 times 5. We are paying the bank $15,000. So we're buying a car for $12,500, but we end up paying them $15,000. Okay, because we have to pay for interest. We just had $13K sitting in the bank, then we could save some money. But it's kind of the irony that a lot of times to save money, you need to have it. But I'm not going to go down that route and talk about that. But it's the world we live in. Anyway, end of the commentary, Jason. Move on. What is the total interest that she's going to be paying? Well, this is how much she paid. This is how much the car was. So the interest is going to be the difference. 15,000 minus 12,625.50. Type that into a calculator. And what you're going to get, because I'm not doing this in my head, is $2,374. That's how much we lose to interest. Well, the longer the car payment, the more interest you're going to pay. The higher the interest rate, the more interest you're going to pay. It's always beneficial where possible to overpay if you're not penalized for it, depending on the terms of your loan. Anyway, that's what's going on here. We got one more example, and then we'll go on to some weirder stuff. We got what are these names? We got Lazy Daisy. I don't know why they're lazy. They just wanted alliteration. You know who's lazy? Lazy is the person who made this workbook. They wanted to use someone named Daisy. What's a word that rhymes with Daisy? Lazy. Sure, you're a lazy workbook creator. She purchased a $300,000 house, had a 10% down payment, and financed the rest with 6% annual interest over 30 years. Okay, so that's going to be example 711. Oh, I'm hungry. Anyway, what's the monthly mortgage payment? Be very careful here because we can't use the formula yet. Because Daisy's not even lazy. Maybe Daisy's productive Daisy. Because she's doing some calculations, some math calculations. She didn't take out a loan for $300,000 because she put 10% down. But we actually need to deal with that first, right? She put 10% down. So how much is left? Well, if you're putting 10% down payment, that means immediately paying off $30,000 of the house. Nice. So there's 90% left, 270,000 left. There are a couple ways you can do this calculation. 90% is 0.9. 90% is left off of 300,000. There's 270,000 left to pay on this house, and this is what she's doing the loan for. Yeah, she's slapping down 30K as a down payment. I don't know how lazy she is. I don't know, maybe she got a small loan of $1 million from her father. I am out of control. This is the last week. After this, you'll never see me again, hopefully. Wait, I just stopped talking. Let's go. Let's go. What's the monthly mortgage payments? Let's copy that formula down again, guys. P naught equals D times 1 minus 1 plus R over K to the negative NK, all divided by R over K. I love copying down this formula. Well, the loan amount is $270,000. Oh, it's this thing again with the algebra. Equals the monthly payments. We don't know this. This is what we're looking for. The monthly payments is D. We don't know D. 1 minus 1 plus R, 6%. Over K, monthly payments. K equals 12. Raised to the negative N, 30 years, times K, which is still 12, divided by R over K. 0.06 divided by 12. So just like before, we need to use a calculator on the top and the bottom, and then multiply by the reciprocal to get to our answer. So let's use a calculator on the top first. I want to save that for later. On the top, that's going to be parentheses 1 minus 1 plus 0.06 divided by 12 raised to the negative 30 times 12. That is our top. Include a lot of decimals. We don't want rounding errors. 0.833958. And our denominator is 0.06 divided by 12. 0.005. All right, so the numerator is that number, calculated it. Denominator is that number, calculated it. We're solving for D, so multiply by the reciprocal on both sides. Those cancel. Those cancel. What you do to the right, you must also do to the left. And you can think of this number as itself divided by 1. 0.005 divided by 0.833958 type this left-hand side into a calculator, and you're going to have some juicy monthly payments. Ew. 0.005 divided by 0.833958. Multiply that by 270,000. Monthly payments are going to be 1,618.79 is the monthly payments here. This much money per month is the mortgage payment. You think that's good? Just wait until part B. So we got a $300,000 loan over 30 years, 6% interest. Part B is asking, what's the total interest that she pays over the whole life of the loan? Well, remember, just like before, we need to figure out how much is she paying. We want total interest, but in order to answer total interest, we need total payments, right? Figure out how much is she paying in total and subtract by the initial loan. And that's going to be how much the interest was. Well, we just found out she's paying $1,618.79 per month, 12 months, and 30 years. This is the total amount she's paying to buy this $300,000 house. And then we're going to subtract that $300,000. And that'll be our interest. Let's calculate this out, shall we? How much is she paying to buy a $300,000 house? 1,618.79 times 12 times 30. She is paying $582,000 for this $300,000 house because of that interest. She's almost paying as much in interest as the house. She's like buying a house for herself and buying a house for somebody else too. Buying a house for the bank. So subtract 300,000 and we'll find out that she's actually paying $282,000, $764.40 in interest alone over these 30 years. So yeah, the lower the interest rate, go for that lower interest rate if you can get it. And yeah, the longer the time period as well, the more interest you're going to be able to pay. Or you're going to be able to pay. You're going to have to pay. So that's loans in a nutshell. Hooray! Good luck. Have fun with the homework.